Hi, my name is Zen Encampment. I'll be going over the KI4, the internal design of a radio circuit. What is desired is that we want to send, say, a voice signal over an antenna and reduce the background noise, keep it small enough to fit in a pocket, and use a low amount of power. This is because your phone has a very small battery, your phone doesn't want to be connected to a cord all the time, you don't want to hear all the background noise like your neighbors yelling, and you want to keep it small enough to fit in your pocket because why would you want to carry around a suitcase? EC312 and EC332 and EC342 are all used. Frequency shifting, filtering, amplifiers, and physical applications of electromagnetic waves. This is the circuit we're looking over. From here, we can see that a voice signal is taken in from this end, sent into an amplifier to make the signal larger, a mixer to change the frequency of the signal, a power amplifier to amplify the signal farther so it can drive the antenna, a bandpass filter to get rid of all the unneeded frequencies, a diplexer so we can run both an input on the antenna and an output, and then an antenna to propagate an electromagnetic wave from this circuit. Antennas are used to make electromagnetic waves. Really, like any wire, you send a current or voltage potential across it, and it'll make a electromagnetic wave around it. But the electromagnetic wave is usually proportional to the size of the antenna. Like this dipole antenna. Dipole antennas create 1/2 of a wavelength, which means it's proportional to 1/2 of the wavelength desired. So, usually, let's say an AM radio station has about 548 kilohertz, and that means it has about a 200-foot tall antenna. Usually they're about 600 feet to get above the ground, but 200 feet is a lot to carry in your pocket, so we're sending fairly high frequency through this thing. The diplexer then is consisting of a low-pass filter and a high-pass filter. This separates the two signals that you send across it, one being higher than the other, and allows you to send it down two different branches without ruining on this first branch here, the antenna. It fixes the problem with walkie-talkies where you have to say over and then the other person may talk, but that's fixed for phones because you don't want to have that problem. You both want to talk at the same time. We then have a bandpass filter. This filters out all the unneeded frequencies, like what humans can't hear. The upper range of what humans can hear is about 20-22 kilohertz. So this is set to get rid of that frequency, and then the lower range is 20 hertz. Gets rid of everything below that. But usually, as we learned in 202, you'll make a bandpass filter out of an inductor, capacitor, and resistor. Inductors are fairly large and generate a whole lot of heat. So, what we do here is we take a low-pass filter and a high-pass filter and combine them together in an amplifier circuit, and that way we get a bandpass filter out of it. We then have a power amplifier. The power amplifier raises the power to drive the antenna. Like I was saying, any normal wire is generating an electromagnetic field. An antenna requires a lot of power to generate one that goes over large distances, say 10 miles in between towers or so. To do this, we employ a large gain amplifier circuit. This consists of a lot of amplifiers to reduce noise in the signal, and it varies depending on the application what setup this could be. A mixer is employed where we have one signal, which is our carrier frequency, then our audio signal going through it. These are multiplied together in the time domain, which means they're convoluted in the frequency domain. This goes into the gate and generates a new signal across the gate, across DS, the drain and source. This new signal is then a frequency shifted audio signal. The frequency shift is usually in the order of megahertz. That way we we only need a really small antenna to make a wavelength that large. You don't want to carry around a 200-foot antenna in your pocket. That's a little cumbersome. Then the preamplifier. This is a picture of a condenser mic and the preamplifier. The use of this is a condenser mic does not generate enough power by itself. So we use a preamplifier circuit to drive the input so that the mixer and the rest of the circuit can read this input. And that way you don't have to power it with your voice. That would take too much. And the amplifier is a fairly simple circuit. It allows us to see that the input goes in and then goes through this op amp, and then it goes out to a speaker in this case. But generally it's taking that low amplitude signal and just amplifying it so that any other part of the circuit can read it, because if we go back to the mixer, the amplifiers require a very large voltage input, and that way they can read the signal properly. So that generally concludes what we have here. We have a voice or some input going in here. It's a very low amplitude, so it needs to be amplified so the rest of the circuit can read it. Makes it more readable for the circuit mainly. Then the mixer shifts the frequency so we can use a smaller antenna. Then a power amplifier amplifies the signal to drive the current through the antenna. And then the bandpass filter cuts off the frequencies we don't need, less to worry about. The diplexer then allows us to use two signals on the same line, and the antenna propagates the signal into electromagnetic waves. Thank you. Have a good day.